Hey guys, I'm here to do lesson 7.3 with you. Your learning target for today's lesson is I will be able to solve one-step addition and subtraction equations. So your think about it says, the bar model below represents the equation b plus 9 equals 15. Use the model to determine the value of b to make the equation true. Then it wants you to explain how you use the model to find the value of b. Go ahead and pause the video and see if you can work it out. All right, guys, we're back. So the first thing that I want to do is I want to determine what are each of these individual parts of the equation. So 15 is going to be our total. Then we have b and 9. Those are both parts. So the 15 is representing the total, the top bar is representing the total, and then we have two parts on either side on the second one. So our goal is to figure out what is b equal. So I see that these two bar models, the first one and the second one, they're equal in length. If you notice, they're the same length, which means they must be equal to each other. So I can take the first one, 15 equals, then we take the second one, and since we're adding, we add them together. So b plus 9. Since I have the total and one part, I can actually use subtraction. So I'll take my total, subtract the one part that I know. 15 minus 9 is 6, so therefore I know b is going to represent the number 6. So explain how I used the model to find the value of b. Well, the two models are equivalent, so let's just take a few notes. The two models are equivalent. Because they represent two equivalent equations. Because they represent two equivalent expressions. The total is 15. Which is represented by the top bar. That also tells me that since 15 and since both bars are equivalent, that must tell me that 15 is made up of the two parts, b and 9. So that's where I got my expression from. Okay, I can use subtraction. To find b, our missing part. b equals 6. Okay, how can we check our work? That's one thing we didn't do. We can substitute b, or 6, back in the original expression. So 15 equals 6 plus 9. 15 and 6 plus 9 is 15, so that is correct. So we checked our work. By substituting for b in the equation. Let's move on. All right, so we're going to test the conjecture. Let's go down and see what it is. It says a bar model can be used to solve one-step equations with addition and subtraction. So that's exactly what we just did on the front page. So let's go ahead and start with test the conjecture number 1. It says, what is the solution what is the solution to the equation below? And then we have d minus 5 equals 7. So this is a subtraction problem. That means the number that we're subtracting from is our total. So d is going to be our total this time. And that means that 5 and 7 are both parts. So I'm going to draw my first tape diagram, or bar model, and this is going to represent our total, d. Then I'm going to draw my second bar model, make sure they're equal in length, and since we have an equal sign. And I know that this bar model is going to be made up of 2 parts, and those parts are going to be 5 and 7. So I'm trying to find out what d is. Well, if d and this bar with 5 and 7 are equivalent, then all I have to do to figure out d is add 5 plus 7. And 5 plus 7 equals 12. All right, so I need to come back to check my work and go ahead and plug it into my original expression, which was d minus 5 equals 7. So let's check when d equals 12. So 12 minus 5 equals 7. 12 minus 5 is 7, and 7 equals 7, so this is correct. Notice that when we did our expression, or our equation, we started with our total, which was the bar model number 1, and then we took the 2 parts, which was model number 2. We added these 2 together because we can see that 5 plus 7, these 2 combined together equal the same length as d. So is our conjecture still true? Did we draw a bar model, and did it help us solve this addition problem? Or this one-step equation, excuse me? It did. So let's move on to number 2. Number 2, test the conjecture number 2, says what value of p makes the equation below true? So I'm going to rewrite it again. We have 15.5 minus p equals 4.8. So again, when we have a subtraction problem, it's what we're starting with that is our total. So the 15.5 is going to be our total. P is one part, and 4.8 is another part. So we're going to use the first bar model to represent the total. So 15.5, and the second one to represent the 2 parts. They're equivalent in size because, again, we're using an equal sign here, so that tells us that the bar models should be equal in size. Okay, and then that second one was made up of the parts, which is P and 4.8. So in order to find our missing value, which is P, we have a total and we have a part. So I'm going to take that total, subtract the known part, and then it's going to give me my variable. So let's plug this information with what we know. Our total is 15.5. The known part is 4.8, and that will equal P. So 15.5 minus 4.8 simplifies to be 10.7. So P equals 10.7. We can check our work by plugging it into the original expression where P equals 10.7. I'm actually going to do that up here. Let's switch colors. So we have 15.5 minus P, which is 10.7, and that should give us 4.8. So let's see, let's subtract 15.5 10.7 minus 15.5. 15.5 minus 10.7. I can't subtract from the 5, so I have to borrow from the 5 here, making that a 4 and turning this into a 15. Okay, 15 minus 7 is 8, 4 minus 0 is 4, 1 minus 0 is 0. So, yeah, we got 4.8. So this sure does, it simplifies to 4.8. 4.8 is equal to 4.8. So did we use a bar model to help us represent this one-step equation? Again, we did. I do want to make sure you guys make this special note. It's really important that we be careful with subtraction problems, with models on subtraction problems. It's very important that you make sure you're picking the correct total.